Somewhere under a rock, an insect the size of your fingernail is about to fire a jet of boiling, corrosive chemical spray from its own body at up to 500 pulses every second. If you mixed those same two chemicals together in a lab, in the wrong container, you could seriously hurt yourself. This insect keeps that reaction inside its own abdomen, and somehow it doesn't blow itself up. This is the bombardier beetle, and what happens inside its body in the split second before it fires is one of the most extreme chemical engineering feats in nature. Inside the bombardier beetle's abdomen are two separate storage chambers, completely sealed off from each other. One holds a concentrated mix of chemicals called hydroquinones. The other holds hydrogen peroxide, the same basic compound in a stronger form that people use to bleach hair or disinfect wounds. On their own, both chemicals are relatively stable. Kept apart, neither one is especially dangerous. But the beetle doesn't keep them apart forever. When it's threatened, muscles around those chambers contract, and both chemicals get pushed into a third chamber, a reinforced reaction chamber lined with its own set of enzymes waiting. The moment those chemicals mix in that chamber, everything changes, because what happens next isn't just a chemical reaction. It's closer to a controlled explosion. Inside that reaction chamber, enzymes called catalase and peroxidase trigger an extremely fast, extremely exothermic reaction, meaning it releases a huge amount of heat almost instantly. Within a fraction of a second, the temperature of that mixture spikes to nearly the boiling point of water. The reaction also produces oxygen gas, which builds pressure inside the chamber and converts the original chemicals into a new compound, a hot, irritating substance called benzoquinone. That pressure has to go somewhere. So the beetle expels it, explosively, out through a nozzle at the tip of its abdomen as a scalding, chemically irritating spray aimed directly at whatever just grabbed it. For decades, this alone was considered remarkable. But in 2015, high-speed imaging revealed something even stranger about how the beetle actually fires that spray. It isn't one continuous blast. It's hundreds of tiny explosions, back to back, faster than you could ever consciously control. High-speed video, filming at thousands of frames per second, showed that the beetle doesn't fire one steady stream. It fires in rapid pulses, as many as 500 pulses per second, each one a tiny individual explosion inside that same reaction chamber. Here's why that matters. A single, sustained explosion at that temperature and pressure would risk damaging the walls of the chamber itself, the beetle's own body. But a rapid series of small pulses lets the chamber vent pressure, cool slightly, and reset between each one before the next micro-explosion fires. It's essentially a pulse jet engine, built out of soft biological tissue, firing hundreds of times per second without tearing itself apart. The beetle can even rotate the nozzle at the tip of its abdomen, aiming that pulsing spray in almost any direction, including directly over its own back, to hit a predator attacking from above. A creature with no bones, no metal, and no engineering degree solved a combustion chamber problem that took human engineers over a century of trial and error to understand in gas turbines and pulse jet engines. And once scientists understood exactly how that pulsing worked, engineers started asking an obvious question. Researchers studying the bombardier beetle's firing mechanism have used it as a model for pulsed spray and microcombustion technology, systems that need to release a controlled burst of pressure repeatedly, without overheating or destroying the chamber that contains it. That research has informed the design of new fuel injection and fire suppression systems, including compact spray nozzles that release fine, repeated bursts instead of one continuous stream, reducing waste and improving control. Some of the same pulsed combustion principles have also influenced experimental designs for small-scale propulsion systems, where engineers need to manage repeated micro-explosions without the engine tearing itself apart. An insect that most people would step over without a second look had already solved, inside its own body, a problem that modern propulsion engineering is still refining today. That's the pattern on this channel. Nature isn't decorating the world. It's solving problems, under pressure, over millions of years, with no room for a design that almost works. The bombardier beetle didn't set out to inspire fuel injectors or fire suppression nozzles. It just needed a way to make a predator regret picking it up. And in solving that one problem, it built one of the most violent, most precisely controlled chemical weapons in the natural world, entirely out of soft tissue. Next time, we're looking at an animal that found a way around death itself. A jellyfish that, instead of aging, can revert its own adult cells back to a juvenile state and start its life cycle over again. As far as we can tell, it doesn't have to die of old age at all. That's the immortal jellyfish. If you want to see how that's even possible, stay close. If this made you look at the natural world a little differently, you're exactly who this channel is for. Hit like if it changed how you see something you thought you already understood. Subscribe so you don't miss the next design nature perfected millions of years before we ever showed up. And tell me in the comments what you want broken down next. I read every one. This is Designed to Survive. We'll see you in the next episode.